This example is giving us an antiderivative that they want us to find here. So they're asking us to find the integral between 0 to 1 of the sine of x squared dx. They're wanting to know about the definite integral, but they actually don't even care about the answer, right? If you look at the rest of the question, it says they just want us to show that it could not possibly be 2, that there's no way the value of this integral could be 2. So kind of bells and whistles should be going off at that point, that most of the time they want you to just go ahead and calculate this thing out and tell them what the value is. They don't really want you to show them it's not something. So that's really something different here. The other thing is if you look to try to take this antiderivative, it's not something that you can easily do. It's not going to fit any of your use substitution. It's not a special case. So you really are kind of left with not being able to really even evaluate that antiderivative. So all of those signs are pointing to the fact that you need to find another way to do this. And the other way that you want to look for when you're trying to show what the value of an integral could be is what they call this Max-Min Inequality rule. It's like the Max-Min Inequality rule for definite integrals. It's like the biggest, longest name in the world. And what it's basically saying, it's kind of applying, really it's applying Riemann sums. What it says is if you have some integral a to b, so if I have some integral from a to b of some equation f of x dx, that I know that this thing has to be bigger than, and again, this is where the Riemann sums come in. So your base, right, Riemann sums is all about area of a triangle. So the area of a triangle is base times height. So you know the smallest rectangle you could use on this to underestimate it would be b minus a, that's your base portion, right? That's normally your delta x, times what they just sort of refer to as f min, the smallest y value that you can find on that graph. So the smallest y value, this they call f min, that would be the height normally. Then on the other side of this, you'd say, okay, well, it also has to live still between b minus a. That's still our base of our rectangle. This time, the height is going to be defined by the maximum y value, the largest y value that we could use to make the height of this equation. So in between those two rectangles, in between that big rectangle that overestimates this integral and the smaller rectangle that underestimates it, is where the actual value has to live. So we take that and we come over here and we say, all right, I have this equation. The hard part really on these is trying to figure out not the b minus a portion. So if I look at this right now, I'd say, okay, I need b minus a times my f minimum. Well, b minus a, those are our bounds. So this is just 1 minus 0. But the f min portion is where things get funky. Always stop for a moment and don't overreact. Look at what you're working with here. You are being asked to find the minimum of a sine function. Sure, what's inside there is an x squared, which seems funky, but no matter what I plug into a sine function, I know that a sine function always has to oscillate between -1 and 1. That's a given of any sine function. So that's why they're giving you a trig function like that to work with. Very often they're going to give you a function like sine or cosine because you need to be able to understand that no matter what I plug into sine or cosine, the most it could ever be is -1, or excuse me, the most it could ever be is +1, and the smallest it could ever be is -1. And so that's why we're using sine here. So I know my minimum value would be -1 of this sine function. And then based upon my little rule, I know that that integral that I care about has to be less than, or that amount has to be less than or equal to this integral here, which is the one I actually care about. And I know that integral has to be less than or equal to, again, we have our b minus a, right? That's just our base of our rectangle, so 1 minus 0. And that needs to be less than that times the max of this. Well, again, conveniently, we're talking about a sine function, and the max of any sine function would be 1. So if we clean all of this up right now, what this tells us is the smallest this could be is -1. and that our integral has to be at least bigger than or equal to that. And then the largest it could be is grabbing this other side here. We get 1 minus 0 is 1 times 1 gets us positive 1. So we may not know what exactly the value of this integral is, but we can say with 100% certainty following our Max-Min inequality that it has to live between -1 and 1. And so because of that, we can now conclude that the value of this cannot possibly be 2, because 2 does not live between 1 and -1. So not possible. So again, something really scary looking notation-wise is a really straightforward idea. Max-Min inequality. You're just really doing a small rectangle with your minimum value, a large rectangle with your maximum value, and you know that your actual integral has to live somewhere between those two. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.